Hi guys, Miss M here again. We're going to continue our lesson on rational expressions, and we're going to learn how to multiply and divide them. It's very similar to simplifying, just some extra steps, but you still have to be able to factor, which hopefully we all know how to do now. Let's see, let me move this up. So we'll start with when we multiply fractions. So when you multiply numerical fractions, what do you do? So let's look at it. For example, let me see if I can get this to pop up. If I have 1/2 times 3/4, how do I multiply that? Hopefully you all remember, and hopefully you all said that you multiply straight across. So you take the 1 times the 3 and the 2 times the 4, and you end up with 3/8. You also have to reduce if it's a fraction that can be reduced. This one is not one that can be reduced. But the same idea of multiplying straight across, reducing, is what we do when we multiply rational expressions. So, for example, what happens if we multiply these two rational expressions? So these are two rational expressions. They're both all numerators and are trinomials, and the denominator here is a trinomial. This one is a binomial. So this one down here we don't have to do anything with, but these three we're going to have to factor using the X method or the reverse Punnett square. Okay, so let's see. So we'll factor this and that and that, and we'll rewrite it. So we end up with x plus 4 times x plus 2, because that's 4 times 2 is 8, and 4 plus 2 is 6. Here we have x plus 7 times x minus 3, because 7 times -3 is -21, and 7 minus 3 is 4. And then for this one, we have x minus 3 times x plus 5, because -3 times 5 is -15, and -3 plus 5 is +2. From here, what we do is we, just like before when we were simplifying, we can cancel things that are alike in the numerator and the denominator. The only thing that's a little bit different is we can cancel anything in the numerator with anything in the denominator. So let me see, I can't get this to, oops. Okay. Let me get my little line up. So it doesn't have to be in the same fraction, it can be over here. So this x plus 2 down here can cancel with this one up here. Anything in the numerator can cancel with anything in the denominator. So this x minus 3 can cancel with this x minus 3. Okay, now there's nothing else that's alike, so that will be my most simple form. So basically, oops, I guess what is happening? You leave it in factored form when you're done. So you take the x plus 4 times the x plus 7, and you divide it by x plus 5. Remember, these x's don't cancel because these are quantities. So this would be our final answer here, x plus 4 times x plus 7 divided by x plus 5. Okay, so we canceled what we could and we simplified. So here's one I would like you guys to try and practice. We're going to do the same thing that we did before. Here we're going to factor out a GCF. This x plus 5 you don't do anything with. And here you're going to use the x method, and you're going to factor both of these denominators, and then you're going to cancel what you can. Okay, so hopefully what you guys got was, let's see, 3x times x minus 2 for this, because the GCF between 3x squared and -6x is 3x. Here stayed x plus 5. This was x plus 5 times x plus 7, and x plus 10 times x minus 2. And then we cancel what we can. So let's get this and cancel. So this x plus 5 here can cancel with this x plus 5 here. And then this x minus 2 can cancel with this x minus 2. And then that's the only thing that cancels are those. So we should end up with, let's see, 3x over x plus 7 times x plus 10. So we just cancel what we can, and then we leave whatever we have left in factored form. So hopefully that's what you guys got for that. So multiplying is not too bad. Dividing is real similar to multiplying. So let's look at that for a minute. When you divide fractions, what do we do? So if I have 2/3 divided by 1/3, how do I do that? If you remember, We use the keep, flip, change method. You might have called it something different. We usually call it KFC, the keep, flip, change. You keep the first fraction exactly the same way it is. You flip the second fraction, and then you change your division to multiplication. So what that looks like is you keep the 2/3, you flip the 1/3 and make it 3/1, and you change this to times. And then you do like we did in the last problem where you multiply straight across, and you get 6/3, which then reduces to 2. So you're going to use the same exact method when you're dividing rational expressions. So let's take a look at one of those. So here we have two rational expressions, and they're dividing instead of multiplying. So you're going to do the same thing we just did with the fraction with the numbers, but we're going to do it with the rationals. So basically you keep the first fraction, so we keep it exactly the same. Keep it x squared plus 2x minus 35 over x squared plus 2x minus 8. Then we flip the second fraction. So now instead of x squared plus 4x minus 21 being in the numerator, it's down in the denominator. And then the x squared plus x minus 12 is not in the denominator anymore. It moves up to the numerator. And then you change your division to multiplication. So you keep the first fraction, you flip the second fraction, and you change division to multiplication. And then now you treat it just like you did the last problem that we did as multiplication, and you're going to factor everything. So I'm going to go over onto this page and I color-coded them so that they all look different so that you can kind of work on factoring. So you're going to factor each one of these trinomials, and then from there we're going to cancel. So let's see. When I factor them, this is what I get. X plus 7 times x minus 5, x plus 4 times x minus 3, x minus 2 times x plus 4, x plus 7 times x minus 3. Then from here, I cancel what they have in common. So I notice right away there's an x plus 7 in this numerator and an x plus 7 in the denominator over here. So I'm going to cancel those. These x plus 3s can cancel as well. And the x plus 4 in this numerator can cancel with the x plus 4 in the denominator. And so then from there, you just write what you have left. So what we have left is x minus 5 over x plus 2, or x minus 2, sorry. Remember, these x's don't cancel. We keep it just like this. So that is what you get as your answer when you divide those two rationals. And I have one for you to practice. So you guys practice this one. You're going to do the keep, the flip, the change. Then you're going to factor and cancel and write your simplified form as your answer. So take a minute and work on this. Okay, so hopefully when you factored, first you keep the first fraction and then you flip this one, right? So you get the x squared minus 5x minus 14 in the numerator and the x squared plus 9x plus 20 in the denominator, and you change that to multiplication. And then when you factored, you should have gotten this, hopefully. And then when you cancel, let's see what cancels. My x plus 5 cancels. The x plus 3 cancels. And the x plus 2 cancels. So I'm left with x minus 7 over x plus 4, where is that? Here we go. X minus 7 over x plus 4. So hopefully that's what you got. You're going to get some more practice in the Desmos activity, but refer back to this if you have questions, and hopefully you took some notes. Good luck, guys.